Right, this is Ismael Torres, and this is problem set 6 for EC 321. We start off with the video problem. All right, we want to find the Laplace transform of x a of t. So we substitute that in for f of t in the general function. Right, so we can split it from 0 to, or from negative infinity to 2, because we know that is 0, and then it only becomes 1 from 2 to 4. And then from 4 to infinity, it's 0 again, right? So we go over here, we do the integration of this. We get negative 1 over s e to the negative s of t with the bounds 2 and 4. All right, so after substituting that in, we arrive to the this is the derivation. We arrive to the Laplace transform of the rectangular pulse. Moving on to section B, we have xb of t equals e to the negative 3 of t multiplied by the shifted unit step function, and that looks like this, right? It starts right here, and then it keeps on going to infinity. So the Laplace transform of that, we substitute that in. Again, we can see that from negative infinity to 2, the function will be 0, and then from 2 to infinity, it will have a non-zero value, which is shown by this integral. Solving that integral, or simplifying that integral by joining these two exponential functions, we get this. This is an s. We can simplify that further over here. This is after evaluating the integral. We get these bounds, and then after that, we keep on simplifying. This, when you substitute in infinity, which is when t goes to infinity, this whole factor becomes 0, and then at the end we get these two negatives cancel out, so we get e to the negative 2 s plus 3 over s plus 3. And then a quick note, right, you can see right here that is if s plus 3 is less than 0, plugging in the fact that t goes to infinity results in the transform going to infinity. So this means that the region of convergence must be where the real part of s is greater than negative 3 for the transform to be valid.